here yx is equal to y naught plus u delta y naught plus u into u minus 1 factorial 2 into delta square y naught plus dash plus u into u n minus 1 dash u into n minus into u minus n plus 1 to delta raised to n by delta raised to n y naught over factorial n for Newton forward difference method. In Newton's backwards difference method formula NBDF, Newton forward difference method, Newton forward difference formula is NFDF. In Newton's backward difference formula NBDF, yx is equal to yn plus u delta yn उल्टा डेल्टा या इनवर्स डेल्टा yn plus u into u plus 1 or factorial 2 into delta square yn plus dash plus u into u plus 1 dash u plus n plus 1 over factorial n into delta raised to n yn. On the following table, estimate the number of students who obtain marks between 75 and 80. First, we prepare cumulative frequency table as follows. Marks about 35 but less than x. 45, 55, 65, 75. Number of students y 18, 58, 122, 172, 192, 40, 64, 50, 20. Delta square y 24 minus 14 30. Delta cube y minus 38 minus 16. Delta raised to 4y 22. By NFDF we have yx is equal to yn u delta yn plus u into u plus 1 over factorial to delta square yn plus u into u plus 1 into u plus 2 over factorial 3 into delta cube yn plus u into u plus 1 into u plus 2 into u plus 3 over factorial 4 delta raised to 4 yn. To find is the estimation of the number of students who obtain marks between 75 and 80. U dash is equal to x minus x naught by h, semicolon h is equal to 10, xn is equal to 85, delta y is equal to minus delta y is equal to 85, u is equal to minus 0.5, y 80 is equal to 192 plus minus 0.5 into 20 plus minus 0.5 into 0.5 factorial 2 into minus 30 plus minus 0.5 into 0.5 into 1.5 over factorial 3 where u is equal to minus 0.5. Delta y is equal to minus 85, it can be into minus 16 plus minus 0.5 into 0.5 into 1.5 into 2.5 of factorial 4 22 is equal to 188.08 approximately equals to 188. Hence number of students getting marks between 75 and 80 is equal to 188 minus 172 is equal to 18. Here by putting this we get y80. Then subtracting from the 75 students marks we get number of students who get marks between 75 and 80. 188 minus 172 is equal to 18. Find a polynomial of degree 3 x3 y6 x4 then y24 x5 then y60 x6 then y120 u is equal to x minus x naught by h, yx is equal to y naught plus u delta y naught plus u into u minus 1 of factorial to delta square y naught x 3 y6 delta y 4 24 x 4 y 24 x 5 y 60 x 6 y 120. Then by subtracting 24 minus 6 18, 60 minus 24 36, 120 minus 6 660 delta y. Similarly, delta square by 18 24, delta cube by 6. By NF df Newton forward difference formula, we have yx is equal to y naught plus u delta y naught plus u into u minus 1 over factorial to delta square y naught, which is equal to x cube minus 3x square plus 2x central difference interpretation formula. Gauss forward difference formula, x y dash x dash dash x1 y dash dash x1 x naught y naught xn x1 x2 y1 y2 central argument y naught, then delta y naught delta square y minus 1 delta cube y minus 1 delta square y naught delta y. Gauss forward difference method is of the form yx is equal to y naught plus g1 delta y naught plus g2 delta square y minus 1 plus g3 delta cube y minus 1 plus dash plus so on. By Gauss forward formula is of the form yx is equal to y naught plus g1 delta y naught plus g2 delta square y minus 1 plus g3 delta cube y minus 1 plus dash. For delta y naught, g1 is equal to u. For delta square y naught, g2 is equal to u into u minus 1 of factorial 2. For delta cube y naught, g3 minus g2 is equal to u into u minus 1 into u minus 2 of factorial 3. g3 is equal to u minus 1 into u plus 1 of factorial 3. Gauss backward difference formula, x dash x minus 1 y dash y minus 1 x naught y naught x1 y1 x2 y2 start from x naught y naught delta y minus 1, then delta square y minus 1 delta cube y minus 2 delta, similarly then delta 4 y minus 2 yx is equal to y naught plus u delta y minus 1 plus u into u plus 1 of factorial 2 delta square y minus 1 plus u minus 1 into u plus 1 of factorial 3 delta cube y minus 2 plus u minus 1 into u plus 1 into u plus 2 of factorial 4 into delta raised to power 4 y minus 2 u is equal to x minus x naught by h. Stirling formula, average GFDF and GBDF. Stirling formula is equal to GFDF plus GBDF divided by 2. Then yx is equal to y naught plus u delta y naught plus delta y minus 1 into 2 plus u square factorial 2 into delta square y minus 1 plus u into u square minus 1 square of factorial 3 delta cube y minus 1 plus delta cube y minus 2 over 2 plus u into u square minus 1 square factorial 4 into delta raised to 4 y minus 2 plus dash. U is equal to x minus x naught divided by h. X naught y naught delta y minus 1 delta y naught delta square y minus 1 delta cube y minus 2 delta cube y minus 1 then delta raised to 4 y minus 2. Stirling formula is used when first neglected highest difference is of odd order, x naught minus h by 4 and x naught plus h by 4. Stirling formula is used when first neglected highest difference is of odd order, x naught minus h by 4 and x naught plus h by 4. Then x1 1.1 1.2 1.3 1.4 fx 0.841 0.891 0.932 0.963 0.985. Function 1.22 is equal to question mark x naught y naught delta y minus 1 delta y naught delta square y minus 1 delta cube y minus 2 delta cube y minus 1 delta 4 y minus 2. By Stirling's formula, yx is equal to y naught plus u delta y minus 1 plus delta y naught divided by 2 plus u square of factorial 2 into delta square y minus 1 plus u into u square minus 1 square of factorial 3 into delta cube y minus 2 plus delta cube y minus 1 over 2 plus u into u square plus u square into u square minus 1 square of factorial of 4 into delta raised to 4 y minus 2. U is equal to x minus x naught divided by s star star x x x minus 2 1 x1 is equal to 1.1 x naught is equal to 1.2 x1 is equal to 1.3 x2 is equal to 1.4 y is equal to f y minus 2 0.841 y minus 1 0.932 y1 0.963 y2 is equal to 0.985 difference table delta y minus 0.05 delta y minus 2 0 plus 0.041 delta y minus 1 into 0.031 delta y naught 0.022 delta y1 delta square y, then here it is minus delta square y minus 2 minus 0.009 delta square y minus 1 minus 0.010 delta square y naught, then here it is minus 0.009, then delta cube y naught, delta cube y minus 2 is equal to minus 0.001 plus 0.001 delta cube y minus 1 delta raised to delta 4 y 0.002 delta raised to 4 y minus 2. Using double star, we have double star means they like this x minus x naught by h, then we get 1.22 minus 1.2 divided by 0.1 which implies u is equal to 0.2 implies v y 1.22 plus is equal to 0.932 plus 0.2 into 0.041 plus 0.031 divided by 2 plus 0.2 square factorial 2 minus 0.01 square का square plus 0.2 into 0.2 का square minus 1 का square divided by factorial 3 0 0.2 का square into 0.2 का square minus 1 का square of factorial 2 then into 0.02 we get 0.939. Maybe here we used the Stirling formula. Yes, it was Stirling's formula. Then is the Bessel's formula. X dash x1 y dash y minus 1 x naught x1 y naught y1 delta y naught delta square y minus 1 delta square y naught delta cube y minus 1 delta raised to 4 y delta 4 y minus 2 delta 4 y minus 1 yx is equal to y naught plus y1 divided by 2 plus b1 delta y naught plus b2 delta square y minus 1 plus delta square y naught divided by 2 plus b3 delta cube y minus 1 plus dash b1 b2 dash question mark b1 is equal to u minus 1 by 2 b2 is equal to u into u minus 1 of factorial 2 b3 is equal to u into u minus 1 into u minus half divided by factorial 3 b4 is equal to u plus 1 into u minus 1 into u minus 2 of factorial 4. Values of when u lies between 0.25 and 0.75, then use Bessel's formula. Whereas when u lies between minus 0.25 to 0.25, then use Stirling's formula. If u greater than 0.75, then use Newton's backward method. Following polynomial use Bessel's formula from the following table: x fx 27 39 412 516 x square minus x plus 12 divided by 2 can be the polynomial answer. X square minus x plus 12 divided by 2 can be the polynomial answer. This one is the Newton. This one is the by using Newton forward difference formula. Function 0.25, function 0.1 is equal to this, function 0.2 is equal to this, function 0.3, 0.4, 0.1, 0.2, 0.3, 0.4 is x, y, then y1, y2, y3, y4, y2 minus y1, y3 minus y2, y4 minus y3, delta square by delta q by x, then minus 0.62049958, then delta y the delta square y, the delta cube y u is equal to x minus x naught divided by h, where x is equal to 0.25 minus 0.1 divided by 0.1. We get, one can get 1.5. Yx is equal to y naught plus u delta y naught plus u into u minus 1 divided by 2 factorial 2 delta square y naught plus u into u minus 1 into u minus 2 factorial 3 into delta cube y naught. Then y 0.25 is equal to tick by putting the values. For example, if the function is not equally spaced, for example, if this function is not equally spaced or the x-axis is not equally spaced, x naught is equal to 0, x1 is equal to 0.6, h2 is equal to 0.9, function x is equal to under root 1 plus x, function x naught is equal to y naught is equal to 1, function x1 is equal to y1 approximately equals to 0.632246, function x2 is equal to y2 approximately equal to 0.31623, or at most to Lagrange's equation. Function x is equal to x minus x1 x minus x2 x naught minus x1 x naught minus x2 y naught plus x minus x naught into x minus x2 x1 minus x naught into x1 minus x2 y1 plus x minus x naught x into x minus x1 over x2 minus x naught into x2 minus x1 y2. I is equal to integration from a to b function x into dx. Then x naught is equal to a, x1, x2, b is equal to x2. Newton-Cotes quadrature formula: let a comma b be divided into n equal subintervals by taking h. Say x naught is equal to a, x1 is equal to x naught plus h, dash xn is equal to x naught plus nh. Then I is equal to nh into y naught plus n by 2 delta y naught plus n into 2n minus 3 over 12 delta square y naught plus n into n minus 2 का whole square over 24 delta cube y naught plus dash. Newton-Cotes quadrature formula: n denotes number of subintervals is equal to width. Then trapezoidal method, trapezoidal rule or trapezoidal rule: n is equal to 1, interval 1 at a time. A x naught y naught, x naught is equal to a, b x1 y1 x1, c x2, xn minus 1 xn minus 1 yn minus 1, b is equal to xn comma yn. I is equal to h by 2 into y naught plus yn plus 2 into y1 plus y2 plus dash plus yn minus 1, which is trapezoidal rule. Then the second formula, which is Simpson's 1 by 3 rule: y is equal to function x between x is equal to x naught and x is equal to xn by delta y naught is equal to h by 3 into y naught plus 4y1 plus y2. I is equal to h by 3 into y naught plus yn plus 2 y2 plus y4 plus dash plus yn minus 2 plus 4 y1 plus y3 plus dash plus yn minus 1, which is Simpson's 1 by 3 rule, which is third rule. Then integration of a is equal to 0 to b is equal to 2, 1 over 1 plus x raised to 6 into dx. For n is equal to 6, solve by using trapezoidal method. H is equal to b minus a by n is equal to 2 minus 0 divided by 6 is equal to 1 by 3, x naught is equal to 0, y naught, x1 is equal to 1 by 3, y1, x naught plus h, x2 is equal to 2 by 3, y2, x naught plus 2h, x3 is equal to 1, y3, x4 is equal to 4 by 3, x5 is equal to 5 by 3, dividing into intervals of 1 by 3, then x is equal to 2, y6, x naught plus 6h, x naught plus h, s naught plus 2h. Then I is equal to h by 2 into y naught plus yn plus 2 y1 into y1 plus y2 plus dash plus yn minus 1. Y naught is equal to 1 over 1 plus 0 raised to 6 is equal to 1. Y1 is equal to 1 over 1 plus 1 by 3 raised to 6 is equal to 729 by 730. Y2 is equal to 1 over 1 plus 2 by 3 raised to 6 is equal to 729 by 793. Y3 is equal to 1 over 1 plus 1 raised to 6 is equal to 1 by 2. y4 is equal to 1 over 1 plus 4 raised to 3 4 by 3 raised to whole raised to 6 equal to 729 by 4825. y5 is equal to 1 over 1 plus 5 by 3 raised to 6 equal to 729 by 1654. y6 is equal to 1 over 1 plus 6 by 3 whole raised to 6, which is 2 raised to 6 is equal to 1 by 65. I is equal to integration from 0 to 2 1 by 1 plus x raised to 6 into dx is equal to integration from 0 to 2 fx into dx, which is equal to 1 by 3 by 2 into 1 plus 1 by 65 plus 2 by sin 22 into sin 29 by dash, which is approximately equal to 1.04043. Simpson's 1 by 3 rule. Integration from a is equal to 0 to b is equal to pi by 2 under root sin x into ds and is equal to 6. H is equal to b minus a divided by 2 is equal to pi by 2 minus 0 divided by 2, which is equal to pi by 4. X naught is equal to a is equal to 0, x1 is equal to x naught plus h is equal to pi by 4, y naught y1, x6 y6. Integration from a to b fx into dx is equal to h by 3 into y naught plus yn plus 2 into even plus 4 into odd. X naught is equal to a is equal to 0, y naught is equal to under root sin x naught is equal to 0, x1 is equal to x naught plus